O1, to be perfectly honest, it was really mostly good at solving puzzles. It was almost more like a technology demonstration. O3 has really been something like a tectonic shift, the trajectory of AI. GPT-5 in some way can be considered as like O3.1. What I am after is something that would be the next pretty significant jump. We understand that there's only one time in history where AI is being built and deployed and developed. We are together in this goal that's larger than every one of us.
Hi, I'm Matt Turk from Firstmark. Welcome to the Matt Podcast. Today, my guest is Jerry Tworek, VP of Research at OpenAI and a member of the Metis list of the world's top AI researchers. In this episode, we go deep on how models actually reason. We also go behind the scenes at OpenAI, how a few big bets get staffed, why everyone knows everything, and how that culture ships fast. Please enjoy this great conversation with Jerry. Hey, Jerry, welcome.
Hello, very happy to be here.
We are going to talk about reasoning a lot in this conversation. At a high level, what does reasoning actually mean? When we talk to ChatGPT and ChatGPT says it's thinking, what actually is happening behind the scenes?
I think that the thinking process is at least a good analogy, as we were in the early days of AI, always had this goal, dream of trying to teach models to reason. We were thinking about it, spending more time to get better results. If like human is posed with a very hard problem in front of them, very rarely they have answers straight away. Sometimes they need to find that answer. Sometimes they need to perform certain computation. Sometimes they need to look up some information. Sometimes they need to teach themselves something. And the process is reasoning is getting to an answer that you don't yet know. In some way it can be called search, but it's not really a very naive search. Search is a loaded word, but reasoning is the process of getting to an answer and a work that you need to do that is longer than what usually is considered answering a question. I think that the difference is here, answering a question usually means you already know the answer and you just elicit the answer you know. And the process of reasoning is getting to the answer that you don't know. And usually the longer you spend on getting to this answer for whatever you need to do to get there, the better it gets.
Mm-hmm. And we've all become familiar since you guys released O1, I guess a little over a year ago now in September 2024, with the concept of chain of thought, which is in layman's term, the little messages that you see when you query ChatGPT and it shows its work, it tells you what it does. What does that actually do? Is that a logical tree and it eliminates option after option? What actually happens?
Language models do on their own fundamental level is they are often called as next token prediction machines. And that's not completely accurate in the age of reinforcement learning, but they still operate mostly on tokens that are mostly text. The language models, again, are these days also multimodal and they operate on mostly text. But to simplify a little bit for a second, language models generate text. And what chain of thought is their thinking process verbalized using human words and human concepts. So the magic that we are seeing why this is all possible is that while you are training on all of internet, on a lot of human knowledge and human thinking process, the model starts learning in some ways to think how humans do, and in some ways get to the answers how humans do from seeing humans do it a lot in the text that was pre-generated and that was based in a training data on humans. And then the chain of thought is basically eliciting that capability in language models of thinking and getting to an answer like humans do. A lot of what early chain of thought work was doing was kind of solving math puzzles. And the first, most famous prompt to elicit chain of thought in language model was so-called, let's solve it step by step. There is this very classical result in language models that if you ask them, what is some, either mathematical expression or some puzzle, and they will try to give you an answer. They will try to predict the next token, but they fail. It's a hard thing. They cannot compute it in a one token jump. But if you ask them, please do it step by step, and they will start thinking, okay, I don't know the answer, but the first step of getting to the answer is this, and then they write like chain of thought, which is a series of text, series of tokens, doing the first part of the computation, the second part of the computation, the last part of the computation. Then they connect those things, and then they can get to the answer. So that the chain of thought is basically a process of thinking encoded in words, how humans would solve a problem on a piece of paper, going step by step from start to the end.
And since time, and by that I mean the time spent thinking, is so important to that concept of reasoning, how does a model decide how long to think when we're in ChatGPT-5 and we're in auto mode and it says that it's going to decide automatically how long to think? What happens there?
It's basically part of our optimization process, partially for the happiness of the users and what they want to expect. Because when you have a thinking process, you need to balance two things, which is like the quality of the result. As we said, and there have been like those pretty great scaling laws that we demonstrate with the release of O1. The longer the model thinks, the better result you get. But also, people don't like waiting. Waiting is time lost that you could do something. Everyone wants to get results as quickly as possible. And there is this saying, you can get cheap, fast, or good, and you can take two. And that applies to language models as well. There is a trade-off, and it's delicate. That's why we also expose some of that trade-off to the users, where you can have like a high reasoning model and a low reasoning models. And this is like in the end the same model. We just tweak the parameter which says we want you to think longer or shorter. And we try to encode some heuristics of what we think the users will want when thinking on an answer a little bit longer, and getting to a better answer is worth it, waiting versus not. But it's a bit of a trying to guess the anticipation of the users. What's the right amount of thinking for them in this particular situation?
Oh, fascinating. So it's more user driven. So it's more like a user experience kind of thing.
In the end, it is, because the question is like, how long do you want to wait for answer? You can always wait longer and get even better answer.
It's been a little over a year since the release of the world's first reasoning model, O1, which is an effort that you led. What has been the journey since? So there was O1, then there was O3, then most recently ChatGPT-5. How would you characterize the evolution of reasoning specifically across the three models in the last year?
In some way, how I characterize our reasoning or scaling up reinforcement learning research program is we do a series of scale-up runs that are progressively more and more ambitious. Everyone, we try to do something more, something larger scale, something that should result in a better trained model than the last one. And obviously, we don't release all the models that we train. Some we release, some we think need to wait a little bit longer for the moment where they will have their time to shine in the hands of the users. But O1 was the first model we decided to release as kind of to demonstrate to the world there are those models. And O1, to be perfectly honest, it was really mostly good at solving puzzles and maybe a few kind of thinking problems here and there, but it wasn't yet very useful model. It was almost more like a technology demonstration than actually really polished product. But we were thinking we have something cool and we wanted to share it with the world as OpenAI. O3, I think changed that pretty significantly. In some way, it is a model that is meaningfully useful and a little bit self-serving. But it was a moment when I started using ChatGPT quite a bit, and I'm basically a user completely hooked on reasoning model. And in ChatGPT right now, I use basically exclusively reasoning models because those are the only models that I trust, the output and the result. And I think O3, its ability of using tools and getting to answer, leveraging a lot of contextual information from various sources and persevering towards getting to that has really been something I think there was a little bit of a tectonic shift in the trajectory of AI And I think we did something really, really great there. Like GPT-5 in some way can be considered as like 3.1. It's a little bit of like iteration of like the same thing and the same concept. And what I am after and my team right now is like something next that would be the next pretty significant jump of how we interact with like models that are even more capable, thinking even longer, and interact with even more systems and sources of information on their own journey. But like separately, in the meantime, we continue to build a lot of things on top of O3 technology, like Codex, which I think like coding agents are at the moment the first like really successful agentic products built on top of AI. There are things like computer using agent. It's called ChatGPT agent right now, I think, and like deep research and a few other things that we will keep on building on like O3 generation technology.
Great. All right. So we're going to go into all of this in much greater detail in a minute. But before we do that, let's talk about your journey. I think it's super fascinating topic, like for all of us. Like you guys are changing the world. So I think I'm curious, and we're all curious, I think, about the people, the human aspect of like who those people are that are, just having such an impact. So you starting from the beginning, you grew up in Poland, I believe, right?
Yes.
So
I grew up in Poland.
Walk us through your formative years and how you got to get started in this field.
Yeah. Happy to do that. An interesting fact: it's almost like a crystal starts from something, and you put a little bit something in the beginning. There's, I think, one part that was like important and part like the starting point of my journey, where I didn't know where it came from, because it was with me from the very beginning of my life, in a moment that I don't really know when it started. It just was always there with me. I always thought that being a scientist and doing science is the highest calling a human can have, and I don't really know where it came from. Like, my parents maybe like were singing the right lullabies to me, like when I was one or something like that. But basically, since I remember, I wanted to be a scientist. In the early years, I also discovered I have talent for those things. I was going to school, and I saw I get things slightly faster than people around me, at least in a regular school and in the middle of Poland, and which made me kind of like doing those things, like studying maths and science a little bit more, because I felt it felt good in a way. Mm-hmm. It felt like this is something that naturally fit me. I grew up as a very regular kid, just being slightly nerdy guy and trying to balance my side of being interested in science, programming, maths, and like having some social life. And I definitely have had some kind of like party arc in my life. But I think that the most important part and moment was when I actually went to University of Warsaw is where I went, and I decided in the end to study mathematics. At around that time of being 18, my idea of life was to be a mathematician with a pencil, sitting in a room with a piece of paper and solving equations. This is kind of my 18-year-old dream of how life should be lived, and what I want to do in my life. And I do have my personality is built again in a way of really appreciating solid science, pursuit of truth, great engineering, and all those aspects. But I definitely have also a little bit of like a misfit, kind of rebellious tinge to it, and that resulted after a few years of studying mathematics. What I realized about myself and about the world is that I really like maths. And I'm quite good at it, but I didn't like academia that much. And I realized I don't want to stay in academia. I don't want to stay in university, and that this would not be an environment where I thought I would be long term very happy and fit in. It felt a little bit too rigid, a little bit too structured in a way that I kind of didn't know if I will feel good. And in some way, for young me, like I was around 21 years old at that moment, that was pretty big crisis of faith for me. I had a moment like, lost purpose of life. So I just did like, a very simple, like first principles thinking. I am graduated with a degree in mathematics. I need to get a job to get food. And like, what job can I do to use mathematics and in that job? And like, looking at the job market at that moment was like, 2011, I think, or 2010, somewhere around that. Like I decided to become a trader and trade for a living as like, the one way where I can like do what I like, which is mathematics, and get a career. I got a quick internship at JP Morgan, investment bank trading floor and equity derivatives group. Spent 6 months there learning a little bit how does trading work and what does it look like a little bit. Finished my degree. I got a message from like boss of my boss at JP Morgan, something saying, "Hey Jerry, you were like one of our best interns ever that we had. We really liked you working with us, and we are leaving bank and starting a new hedge fund. Would you want to come with us?" And like for 20, 21 or 22-year-old Jerry, that sounded like kind of like a cool adventure type of story that I was interested in going there and do it. It had enough interesting problems to be solved, and at the same time it had this kind of trying something new, trying something ambitious kind of bit that I generally like. So I was in London. That company didn't really work out, unfortunately, but it was hard and ambitious, and not everything works out. I did try that again, starting another hedge fund from scratch with a few other people in Amsterdam. I worked there for a few more years, and eventually I got bored. Like I generally working in trading is an interesting and exciting problem. Market is very hard. The depth of what you can go of trying to understand it model is very deep, and I worked with pretty smart people overall, but I stopped feeling I am growing after a few years of doing that. And at the same time, together with a friend I was working with, we just started chatting about AI and about this like artificial intelligence. And what really drew me to artificial intelligence was reinforcement learning, and specifically the DQN agents trained by people in DeepMind in like 2013. But I think it was a few years later that I actually learned about those results. From my perspective, and again, this is just how my brain works. The 2012 ImageNet results like weren't that significant. Like during my university years, I learned a bunch about like how classical AI, the neural networks weren't very fashionable back then, but I still learned about what they are. I learned about SVMs and all kind of methods, how you train classifiers. And for me, it was kind of like obvious and natural. Oh, if you have enough parameters and tweet it hard enough, you will fit a classifier to whatever you want. It was kind of obvious. What was to me not obvious is I never considered classifiers a smart thing. Classifiers, you learn a function on some set of inputs to some set of outputs, and you can keep training it to approximate better and better. What was something that I missed back then is that when you can fit any function better and better, you can start shaping behaviors and strategies. And when I really saw that was in the like DQN results, where they applied the same things that worked in ImageNet, like neural networks, and they weren't particularly big or impressive neural networks, with a classical field of reinforcement learning to solve simple computer games. And turns out those simple neural networks with a simple learning algorithm started learning pretty complex computer games and exhibiting very interesting behaviors. I saw those behaviors, I saw those results, and I was like, this is what I want to do for the rest of my life, which is like, not very long horizon with the 20-something things. about, but I was like, this is what I want to do. Where do I do that? Like, Google search, where are places where you can do reinforcement learning in this world? Google DeepMind and OpenAI came up with this kind of, at that moment, pretty small and like somewhat known, but they were...
Yeah, you joined OpenAI in 2019, right? So like very much, very much in the early days still, very much in the kind of like non-profit era of OpenAI. How did you connect with them?
I just applied through the website. The most like boring and uninteresting thing in the world, which is like, OpenAI.com jobs, like, apply, send resume and hope they respond. And then, like, luckily enough, they did. I don't know how many resumes OpenAI was getting in that time. I think it's definitely much less than today. But I was like, I came there and I was like, no, that doesn't matter what do I do as long as it's reinforcement learning.
So you joined in 2019 and with a passion for reinforcement learning. So was that around the Dota 2 moment? Because OpenAI, interestingly, in those early days of 2019, did a lot of reinforcement learning focused work, right? And then there was a whole like unsupervised learning GPT moment that happened afterwards, but like it started from roots in reinforcement learning, right? So did you work on that project specifically, or was it too advanced by the time you showed up?
So the project that I worked was Robotics project at OpenAI, which shared the same code and same methods as the Dota project. Like in one hand, the Dota project was OpenAI's way to demonstrate the world what scaling up reinforcement learning can do. And in some way, it was like taking the 2013 DQN agents and just doing all the hard work of making it bigger and bigger and solving harder and harder problems. And OpenAI generally from the very beginning was aware and really like, it was simple but genius insight that you need to have large scale system to learn really, really interesting complex behaviors. And that was like one way of what Dota was trying to show, that by scaling up reinforcement learning, we can solve pretty complex environments. And then there was another project. There were, I think, 3 reinforcement learning projects at OpenAI at that time. And the second one was Robotics, which is applying the same methods that we now knew or were proving that can solve pretty complex computer games. Can they solve all the practical problems? OpenAI was always optimistic and ambitious and trying to see if we can scale around to solve Dota. Can it load my dishwasher? Can it fold my clothes? Can it build a house? And this is what we are doing. The project I was working on was focused on dexterous manipulation, which was back then and still continues to be an elusive challenge for trained policies. And we got to a showcase of demonstrating that a hand controlled by neural network was able to solve Rubik's Cube, which is a pretty delicate and a complex task to do.
So fast forward to today, still in the same vein of the behind the scenes of you all at OpenAI and sort of life there. What's a day in the life of Jerry? What does somebody like you do? You read papers, you train models, you manage teams. What's a day like?
Yeah, my days are surprisingly uniform, which is I come to the office early in the day after driving my kids to school. Then what do I do all day is basically talk to other researchers. I talk to other researchers all day, every day, and this is basically exclusively what I do. I take ideas from people, bounce with them, brainstorm with one partner, then move to another one and do the same thing over and over and iterate. And in that case, in that way, keep refining our research program. Sometimes those are group meetings, and group meetings are there as well and have their own team dynamics, but that is basically exclusively what I do. The only thing that changes is the topics of research from meeting to meeting and from person to person.
How are priorities in research determine? There's a range of possible projects. Is that top down? Is that bottoms up? Do people suggest ideas and others vet them? How does that work?
Yeah. It's the art of like structuring, organizing, and leading a research project is like something that I generally like learned to appreciate very quickly in OpenAI's journey and in my career. There is something we are good is structuring research projects, and I think it's a unique mix. Like you cannot say it's top down, you cannot say it's bottom up. It's a mix of those two, which is balancing all the important aspects. Which is one thing OpenAI embodies and determines is like we all work on a very few projects total. There are not that many projects. OpenAI is not trying to do everything. We are not trying to like have portfolio. We are trying to have like multiple different bets. Always the idea is we do few core things really, really well and put a lot of effort there, which means there needs to be a lot of people working together on the same large scale, large ambition project. And we have a few of those, small number, probably 3 or 4, depending on how do you call it, and that's it. And from that perspective, like people don't have ultimate freedom. It's not that people come to OpenAI and say, hey, I want to do this, and they just do this, because you need to do something towards the goal of one of those 4 projects. And then within those projects, like we try to be like relatively bottoms up in a way, as long as it feeds again into those goals. And the most important part of the research lead is keep to making sure all the researchers are working towards this one shared goals and that don't fracture in their own ways of thinking and doing things. And so it's an incredibly hard thing. It's a very, very hard job, and not always easy to visible how delicate it is. But that's a lot of what it is. Like I don't think top down structuring of research doesn't work in research organizations. I really don't believe in it, because like you are not kind of hiring some of the smartest people in the world, and OpenAI has incredibly smart people to kind of tell them what to do. They need to figure out what to do, but they cannot figure out in the whole space of things what are cool things to do. They need to figure out from within the space of what the project needs and what could advance the research goals of OpenAI the most.
And to which you're saying, is there collaboration between the teams working on the 3 or 4 projects at the same time? Because I would imagine, putting myself in your shoes, OpenAI shoes, there is probably a tension between wanting to be collaborative in general, but equally, this is probably the most important IP in the world. So you probably want to make sure that not everybody knows everything about everything. But perhaps not. I'm speculating here. How do you think about that collaboration versus some protection of IP?
You'll be surprised, but the truth is, in research at OpenAI, which is like around like slightly less than 600 people at the moment, everyone knows everything. Really it does. And we always have been fully transparent. And it is like, in some way, you are a little bit shooting yourself in the foot if there is a researcher that doesn't at least like have the chance to learn about everything, because they don't have the best information to do their job in a best way. And like it is like, yeah, it is some like risk of losing IP, but I think the risk of not doing the right thing and of people not being informed about research and not being able to do the best research is much higher, in my personal opinion, and how I approach those things. So we are extremely internally transparent within research, and that is one of our operating principle, as the goal is to do the best research we can and train the best models we can consequently. And the culture generally is very collaborative. Like, it is always the case when you have 600 people, when you have groups of people, they're always like, one person doesn't like the other person because they looked at them weirdly, or one person thinks the other smells bad, or just doesn't like their ideas. Like that does happen. Those are humans, and those are human things. But generally, in large scale, I think we really have this belief, like, we are together in this goal that's larger than every one of us. It is a very positive sum game, because the AI seems to be getting only more and more significant, and the success of OpenAI is far from guaranteed. It depends on us doing great work every day. So there's a lot of like feeling of shared fate and the fact that we all need to rely on each other to do our job to achieve this shared mission. So I generally like think with all the caveats of human nature getting in the way sometimes, I think on a large scale OpenAI is very, very collaborative.
How do you all manage to keep that pace of releases? Like it seems to me from the outside that there's a tension again, like between one other kind of tension, like between research, which in some ways is kind of feels like it could be a long-term kind of thing, and on the other hand, like you guys seem to be just shipping across the organization, but including in terms of like core models, like again to the point that you went from O1 to O3 to GPT-5 in like a year. How do you balance all of that? Like why are you guys able to ship so quickly?
I think the fundamental reasons for it is, in general, OpenAI kind of, in my at least worldview, is a generational company in a way that we have incredible momentum behind us. We know that we were doing pretty great in the past and we need to continue that. We have incredibly smart people, like literally the most talented people in the world are all coming and want to work at OpenAI right now, which means like every output per single person is incredibly high, and everyone really, every single person does a whole lot. So we have like momentum that carries us forward. We have really great people that work together. We have like good operating like way of structuring research and can borrow a lot from Silicon Valley how to get things done quickly. And people are generally very excited about work. Everyone feels the weight and potential of what we are doing, what we are trying to do. And because of that, people at OpenAI have a tendency to work pretty hard. And like, having great people excited about what they are doing, all working together reasonably well, generally results in doing a lot of things. We understand that there's only one time in history where AI is being built and deployed and developed, and people want to do it in the best way that is possible.
Do you all use a lot of your own tools? I think Fiji Simo was tweeting the other day that I think in the latest, what you all announced at Dev Day today, a lot of it was written by Codex. Is that part of the daily experience? Do you use a model to come up with new ideas for models? Do you use Codex to write the code? How does that work?
Yeah, we definitely use Codex a lot for coding, and this is only getting better. Like as I said, I use ChatGPT a lot, although not surprisingly not that much for actually coming with ideas, but like for a lot of questions that I have, I think I am pretty heavy user of ChatGPT right now, happily paying like $200 a month for it, and I think
they make you pay
for what it's worth. They are making me pay, and I'm kind of like pretty okay with this, because then you get pretty generous like usage limits and not really bottlenecked on it.
Thank you for all of that. Let's switch tacks and go back to how all of this works. So is the right way to think about modern AI systems at OpenAI, by modern, I mean as of October 2025, versus the old days of, 9 months ago? So exactly. So is the right way to think about it as a combination of pre-training and RL? First of all, is that the right way to think about it? And second, if so, just at a high level, how does the articulation between both of those work? And then after that, I'd love to do a little bit of a deep dive on RL to make this very educational for folks.
Today's language models basically can be thought as like, first they are pre-trained, then you do reinforcement learning on it. Like the reinforcement learning would not work without pre-training. And I think in a similar way, like pre-trained models had a lot of limitations that are very hard to like resolve without doing something that looks like reinforcement learning. So I think both of those bits are here to be and to stay. Like I think the way how they are like combined and done may and probably will evolve in the future. Nothing should be treated as dogmatic and fixed. And we need to keep generally figuring out the way how to train better models, and this is what we are trying to do. The interesting thing, and I can credit that to Ilya, how much foresight that he had. But whenever I was started at OpenAI early 2019. Right, and like I remember there was like research all hands or something like that, where Ilya came on stage and talked about like what is OpenAI's research program, what are we trying to pursue, and what he said at the beginning of 2019 was to train large generative model on all data we can, and then do reinforcement learning on it. That was the OpenAI research plan at the beginning of 2019, and this is exactly what we are doing today. The algorithms change, architectures change. Like I don't think he was even thinking about transformer at that moment. Like the GPT was like there was some GPT, but it was like a toy example that someone was playing with. But the goal of training large generative model on all the data in the world and then doing reinforcement learning with it was already there at the core DNA of OpenAI, and that's what is happening right now.
So let's do, if you will, a little bit of reinforcement learning 101 to make this really interesting to like a broad group of people listening to this. So in very simple terms, like explain it to me like I'm 10. What is reinforcement learning?
Yeah. I usually the metaphor and the analogy I have to reinforcement learning is like training a dog. It's very, very close. And I used to have a dog when I was a teenager. And even what I remember my parents did, like, I didn't know anything about raising a dog. What they kind of invited through some friend of a friend, a fireman, who I think was working with like service dogs. And he came to me and he basically told me a little bit about how do you train your dog. And what most dog owners that are like ambitious about training your dogs know, it is always extremely important to have a bag of treats in your pocket. That's what you always do. And whenever you see your dog behave well, what you should be doing, you should smile and you should give your dog a treat. Whenever you see your dog do something bad, you basically like give your attention away, turn away, and become sad. And through the years of breeding, the dogs discover it's a like bad reward and bad behavior. And this is exactly doing that, but with models. We elicit a lot of different behaviors in the models, put them in challenging situations, and then we give them cookie if they do something we want, if they do a good thing, and give them some kind of punishment and negative reward if they do something like that we don't want and that we don't like. In a good way, the good way to do RL is if you balance those things. So if you kind of give cookies half of the time and punish the other half of the time, but this is almost like a mathematical kind of aspect of it. But that's the most important part, which is like elicit behaviors, reward the good ones, and then going forward, the model will be more likely to do what you want and less likely to do what you not want, and through that, it improves. It is the way how to train models to like elicit actual behaviors. That is not first next token prediction. If you pre-train a model, you literally train the model to predict the next token. RL is like a completely different gradient and a completely different set of what we want to get out of the model. And
getting the model to do what you want, just for some vocabulary and semantics, that's, you hear sometimes the term policy. So in RL, you hear terms like agent, environment, action, reward, and policy. So I think a lot of those are sort of self-explaining, but policy is that's a strategy, that's a behavior of the model?
Yeah, policy is the behavior of the model, as the model weights represent what it does when put in a different thing. Like model in the end is a mathematical object, and you can define it, and a policy is a mathematical function that maps observations to actions, what you see, and then what you do with what you see.
Yeah. So agent is a model, action is what the model does, reward is how you say whether that's good or bad. Environment, you hear a lot of things these days about designing the right environment for RL. What does that mean?
An environment is like, in some way it is everything that the model sees, but the interesting thing about difference about RL environments and most other types of like what you can call supervised learning or unsupervised learning is that reinforcement learning environments, you want them to be interactive. You want like them to evolve as the model does things. In general, like similarly how like if you want to like learn how to play guitar, you kind of take a guitar and you strum it, and what happens is you hear sound of that, and then you hear it, and then you can do like learn to play like with actual like feedback of what is happening with the guitar. And in a similar way, the environment is like how does the world react to your actions, and a lot of like what drives your actions is what is happening in your environment, and it's in your world. And that's kind of like the only way how to like really teach agents to like learn to react to changes in the environment is through reinforcement learning.
Can you give us a little bit of a bird's-eye view of the evolution of RL over the years? What mostly how does modern RL differ from sort of historical RL?
Yeah. Again, there was super historical RL, like it's not even that old, but the main like tectonic shift was when combining neural networks with reinforcement learning. The reinforcement learning predates neural network as a general mathematical method of optimizing behaviors in like mathematically defined environment, and as a method of study.
That's what is known as deep reinforcement learning. Is that
yes,
right?
And then the deep reinforcement learning, that basically like DeepMind invention of combining neural networks with reinforcement learning to the DQN moment I talked to you about. And then from there, like there was a moment where like there was a pretty active like area of research of reinforcement learning on games. Like when I started like 2019, the reinforcement learning was kind of fashionable at that moment, although not like very successful, but the reinforcement learning was able to solve a lot of games. But the bottleneck was there that the models were not pre-trained in any way. We were training a lot of behaviors playing games. Like we even got AlphaGo moment out of that, which a lot of people got very excited about it, but was still like learning behaviors without the models that were meaningfully smart about those behaviors. There was still a lot of kind of like, you don't want to call it caveman intelligence, but something in that regard about models not being really smart, even though being pretty heavily reinforced. And there was like a long research in that, and a lot of cool like results and theoretical understanding of RL comes from those days because people were researching RL actively. But it was like in some way it was a dead end of doing RL without pre-training. And then like in my like moment when I finished like working on robotics, I started working on teaching language models to code. But having pre-trained models was a really big deal. And the GPT era of scaling and of like large scale ingesting lots of data to really train great models, like enabled us already at that moment to start RL, and that was one of the first things I did almost immediately. Whenever GPT-3 was trained, I tried to do RL on it, and there were always were bottlenecks. The systems were kind of clunky. It was hard to figure out what are the right algorithms, what are the right what are the right problems to work on it, and what is the right algorithm to train it on. And like what OpenAI did at that moment, and what was kind of like how research goes, we kind of cargo coded a lot of things that was used for games, and almost the same things are for robotics. And the first RL I was doing on large language model was kind of the same PPO we used for everything. And like it gave some results, but those like early results weren't completely mind-blowing in RL. And there was a long time where we're keeping on investing in it. And personally, I always believed there will be a really big moment for RL and language models, but definitely the early trials and errors weren't super successful at the moment when we trained GPT-4, and there was an interesting moment where we trained GPT-4, and everyone today thinks, oh, GPT-4 is such a great model, but when we trained GPT-4, we were pretty underwhelmed internally, and there was a lot of moments, oh, we trained this model, we spent a lot of money on it, and it's kind of like, pretty dumb. At least like, we have GPT-3 already does all that stuff, and GPT-4 doesn't really seem to be that much better. And like we had this like kind of question, like, how like it kind of seemed smart on evals that were like 1 token long. It seemed to be able to give like pretty detailed answer to complex questions when it was 1 token. But if you actually let it speak for longer, it wasn't very coherent or really like give very long answer. And we need to answer this question: how do we like actually make the language model that seems to have some smartness in its way, it's actually sound smart and actually be good in talking to it? And that was the moment where a technique that was developed already a few years earlier, like really shown, which was called RLHF, which is basically doing PPO on large language models with the reward given from human preferences of seeing 2 parts of that text.
Thumbs up and thumb down.
Yeah, thumbs up, thumbs down, like whatever human preferences is. And that's a very good reward, because there are a lot of things how the model can generate bad text, and how early GPT-4 was generating bad text in a lot of ways. And RLHF was able to catch those things and correct it, and reinforce good behaviors, reinforce generating good text, and then punishing bad text. And in the end, GPT-4 plus RLHF together as a package, like delivered the ChatGPT moment to the world that everyone sees. And as much as it is a big success of pre-training, it actually also was pretty big success of RL in the form of RLHF.
Amazing. And just to double click on that, the RLHF, so we all familiar as users with, I mentioned thumbs and thumb down, that's on the interface, but the actual RLHF happened post-training. Is that right?
Yes.
And what did that look like as an effort? Did you have like a bunch of just humans sitting down, in front of the model, industry specialists maybe, and give it feedback? How did that actually work?
RLHF was a research program that was already it was already happening in the background for a while. I think we did RLHF. At least I remember GPT-2 being RLHF for quite a bit, and that was already there and already happening. And it's like gathering data for RLHF in its own like research domain, basically, and always thinking what is the right data to train the model, what is the right data to train like your rewards, and how to shape your rewards. It's a research that we've been doing, and it's a very open-ended and very deep in many different ways. And I think there are papers written on what RLHF is, but there's a lot of depth to it. But the long story short is you have what we call AI trainers these days, and they look at outputs of the models and they give them scores, and then you learn basically a model of those scores and use that for training.
And that's part of, for people who may be curious, like the entire data labeling industry, so Scale AI and a bunch of others, that's what they do. Right.
Yes. I think, in a way, I think it's getting more and more to be a thing of the past as the models are getting smarter and smarter. This is becoming less of a thing. But I think a few years back, and especially in GPT-4 days, this was the thing. The interesting bit about data labeling industry, I'm not sure how much we want to go on that tangent, is that it has to constantly reinvent itself, because the AIs are getting smarter. And at some moment, like certain things you don't want to label with humans if AI already can do it. So like you need to you move the frontier and you change the type of data you are labeling as you already RLHF the previous part.
We've been talking about RL, but the first phase of all of this is the creation, the pre-training of the models. That is unsupervised learning, right? Do you want maybe to make this broadly interesting to people, define unsupervised versus supervised, and in what way was the pre-training unsupervised versus self-supervised or whatever nuance?
Yeah, I think those are nuances, and I don't think they are as stark and as sharp as some people like to determine them. But the why like pre-training is called unsupervised, because like in some definition of it, you don't need any like extra labels to the data that you feed into the model. You just feed the text as this. In some way, you may argue that the data is already labels because it is self-labeled. If like you give them all from the text, predict the next part of text. Like in some way, it is a label, but it is self-supervised because like we don't clearly tell the model like what is right or what is wrong or what do we want from it or what do we not want. We want it to just predict the other part of data. You can do the same thing with images. You can mask the part of an image and tell them all like predict the next bit of image. But whenever like there is this like classic machine learning notion of like targets and labels, like I guess we were talking about classifiers. So supervised learning was like you have some notion of targets, what your targets are, and some notion of labels. Supervised learning was like predict those labels from targets, and this is like some type of mapping. But actually, what's interesting is that there are many more bits usually in the targets than in the labels. And studying the structure of targets itself, it yields much more learning and much more intelligence than learning the mapping itself. So, like spending a whole compute on just learning the data itself without the labels is the right thing to do, and like what is often called like representation learning and studying the data and its properties.
Okay, great. All right, so going back to RL, you tweeted the other day, GRPO, the GRPO release has been in a large way has accelerated the research learning program of most US research labs. So what is GRPO?
Yeah, it was a little bit of a tongue-in-cheek moment. I am extrapolating here a little bit what exactly happens because I haven't been in most US research labs, but I have some mental model of what happened and how. And like, long story short, GRPO was the open source released from DeepSeek, and there was like everyone who like is terminally online and follows AI discourse knows the DeepSeek moment of whatever it was when the Chinese company that seems to be doing really, really great work released new model, and it was also pre-trained model, a reasoning model. They open sourced the algorithm, they open sourced a lot of things they did. Overall, like really, really great and technically excellent release. And like there was a lot of discourse about that they pre-trained their model particularly cheaply. And that was part of the discussion about the DeepSeek moment. But the other part of the discussion was that they kind of like released their reasoning process. It was like not very far after our O1 release. And as far as I know, like our O1 release mostly caught a lot of US labs by surprise. They didn't have like similarly advanced RL research program to my knowledge, basically no one. And I think like the only company in the world that, again, as I am aware, there's probably a lot of things I didn't know, but you talk to people sometimes, you hear rumors. So this is my version of the world, is that if you look at the older papers of DeepSeek, like that company was doing pretty similar in some ways RL research to what we are doing. And I think I have to clarify, like, what OpenAI is doing is not exactly GRPO. It is slightly different in many different ways, but like some parts are definitely similar. And what's most important, those are both like large-scale policy gradient algorithms. And like DeepSeek company was doing research in a slightly adjacent area. They were not very far. And whenever we released O1 and we told the world that you can get pretty like those great results with scaling up reinforcement learning on language models, I think it was like not very big hop for the DeepSeek company to kind of realize, okay, we are not very far from getting similarly good results. And they did it. They trained their reasoning model and they released it and they told the world how. Pretty like not much later than we released O1. And I think like, for a lot of US research lab that didn't didn't have a research program how to train like reasoning models. They looked, there's this like Chinese company, they released how to do it. It helped us kickstart and train reasoning models much faster than we would have to otherwise if we would have to find all those bits ourselves.
What does it take to scale RL? So if there was a phase where OpenAI was very focused on pre-training, and then, if I understand correctly, the last 12, 18 months or whatever time period where the emphasis has been on the sort of second part of the plan, which is scaling RL, is that a question of just giving RL more compute, more data, more labeling, as we were saying? What does it take?
The first thing that is important to know and understand, RL is hard. Like conceptually, if you think about it, and there's still a lot of depth to it, but very conceptually, mathematically speaking, pre-training is that simple. It is kind of the simplest thing you can do, and there has been a lot of thought and a lot of optimization already put through a few years of optimizing and doing very well at very large scale, very simple mathematical operation. In terms of RL, it is much more complex. There's many more things going on in a reinforcement learning round. There's many more things that can go wrong in doing it, especially as you scale up, and many more types of bottlenecks, failures. Like it's a much more delicate thing, and there's much more much more room for error. In some way, I don't want to go too deeply in that parallel because it's a little bit overblown, but in some way, just to give some coincidence, you can have a steel factory, which makes steel, and the process is relatively standardized, and you make blocks of steel, and they are uniform and nice and well defined what it is, versus building semiconductors, which there are very few companies in the world that can do it, because there are so many things that can go wrong, and you have to put a lot of attention to details to make great semiconductor, and it's very complex internally, and in many ways this is kind of I don't want to diminish, because there is a lot of very hard technical difficulty to do pre-training well at the large scale, but there's just many more moving pieces and many more elements of the reinforcement learning stack that need to get right to get a large scale run successful.
You mentioned working on a ChatGPT agent, like the Agentic AI. Where does that all fit? The tool use, the whole agentic autonomy versus reasoning RL. Help us to sort of reconcile what does what and what impacts what.
I think what is the important thing is I believe and I think that there can be a lot of positive impact of AI on our world and on our lives through automation, through problem solving, and through AI doing good things for us, the things that we want. And for a long time again, it's not that long, but the last 2 years or so, or maybe approaching 3, we've been living in this world where we kind of ask questions to AI, and it gave us an answer at the beginning instantly. Now it can think for a minute or 2, which feels long, but in many ways, what can you do for 2 minutes if you think of how many problems humans solve? And AI is probably a little bit faster in the things it can solve, but it's still a limit of what it can do. There are still a lot of tasks that that would take AI to do much longer. When I prompt codex, it works for a while. Again, few minutes. There are a lot of things we have internally and we are doing that allow them all to work for much longer. We still didn't figure out the right product to deploy them, but the models can think for 30 minutes, hour, 2 hours these days on certain types of tasks and problems, even longer than that. They generally are capable of doing so, and we need to figure out how to make that process more useful and more being able to actually come to various problems in real life, whatever it is, coding or booking travel or making plans or even designing houses or new electronic devices or whatever else you would like models to do. We would like them eventually to be able to do for us. And a lot of this comes through the models thinking independently for longer periods of time and considering more of our alternatives, bits, and just sometimes going through a slog of very long lists of tasks.
So the agentic part is powered by fundamental reasoning. Is there a concept of I guess online RL that happens where as the agent does something and learns from the real world, the RL happens in real time? So
in general, all of RL is happening. Most of RL that you hear talk to language models is online, but it's done online in a way that is still a training run. It's still being trained kind of separately from the user. There have been a few models in the world, and I've learned recently that I think Cursor is trying to train some models online with their users in the loop, and it is theoretically possible to train models again in ChatGPT or every other product, just responding to the users and reinforce through whatever rewards you get in there. But this is not what I am aware, at least like not what OpenAI is doing at the moment, and it's can be great, but it can be also dangerous because you are not really very much controlling what you are reinforcing in that loop and what could happen. So at least until we have a really good safeguards, I don't think we should try to do that in anything like as complex and large scale as ChatGPT.
Yeah, interesting. And very much on that note, talking about alignment for a minute, is alignment an RL thing? I mean, is it
yes.
Do you create alignment in the model by teaching it what is right and wrong?
Kind of. Yeah, it's a little bit of yes and a little bit of no. Like in a way, alignment is about steering the models to certain behaviors, and that is definitely an RL thing and an RL problem. But also, you want the models to know what is right and what is wrong and understand the world. And not all of them are like reasoning and RL problems. Those are very often like just as AI problems, and we like. In the way to be aligned, the model needs to know right or wrong to choose right. I don't think like you can just tell the model like show it few good things to do and it will do. The model needs to deeply understand its action and consequences to really be able to choose the right thing. And I think it's a never-ending pursuit because like even for humans, it is not super easy to define what do we consider aligned. And I think as our civilization will evolve, the notion of alignment and the goals of humanity will keep evolving, and we'll need to keep nudging the model towards those things and keep explaining to it the things that we want from it. But it's a very definitely very important and central part of any should be of any AI research program.
Yeah, which brings a whole next series of questions of where RL is efficient versus less. So it seems that it's been particularly good for like math and coding, and then the next obvious question is what about the rest of the world? But like taking a quick sort of going down the rabbit hole a little bit about math. So just in September, like just a few weeks ago, you guys did something unbelievable with the ICPC World Finals. You want to talk about what that was and what went on from a model technical perspective behind the scenes?
There happened surprisingly little from our perspective, from the model perspective. We just have a pretty smart model, and then when we ask them to solve programming problems, they are correct. Like what's a little bit of a backstory in it is that I think we used like specifically programming puzzles for a while as a very nice research test bed of our ideas. Those are nice problems to experiment on them, and they weren't ever like considered part of the product, but those are pretty like complex problems and they require a whole bunch of thinking, are very nice to give rewards to it. So a lot of researchers just liked working on those problems as a way of trying out their RL ideas. Like you always need a data set. I'll take a data set of programming puzzles and try it. And I think like because of that a little bit, our models just were always very, very good at competitive programming as a kind of byproduct. We never tried to be good at it, but like researchers were trying their ideas on it, and because of it, like every training run, whatever we are doing, just end up being very, very good at those type of puzzles. And then like it was a little bit of a formality for us to kind of like to go and submit that to a competition and like do it's like largely about demonstrating to the world how like what is the level of capability in those models. But I think it is important and true to acknowledge that in not all domains, at least like comparing to human baseline at this moment, we can be as nice and as good as in programming competition problems in many ways because those were like tried for a long time by many researchers, and researchers don't always spend as much time as they could, and I would like them to on very practical problems that people go to ChatGPT or our models with.
Great. So it sort of came out of the box. There was no specific training for it. And just to remind people, so what I'm referring to, what we were discussing is the ICPC World Finals that was just in September 2025, which is International Collegiate Programming Contest, ICPC, that happened in Baku, Azerbaijan, where OpenAI solved 12 complex algorithmic problems within a 5-hour time limit, basically making it take the equivalent of first place in front of human teams. So just for context.
We did a little bit of a round tour of various competitions. We did ICPC. We did also like IOI, International Olympiad of Informatics, earlier this year, and AdCoder Heuristics competition as well, where we went second behind a single human that is also a Polish person that used to be employed by OpenAI some time ago. Funny coincidence, but I think we were looking for a moment in time where our models are kind of like smart enough to be able to compete in those competitions with some of incredibly smart and talented humans, but it wasn't never our particular goal and focus. It's kind of like we think if we are doing good research for training smart models, they should be smart enough to do those things, and we kind of like tick that milestone, and now we keep on moving forward, and I hope we will see. And I think we are already seeing more and more practical and tangible things coming out, like every week or every other week on Twitter. I do see what I think are credible reports of actual scientists using some of our reasoning models to help them perform calculations, solve hard technical problems with our models. And I think this is like where we want to be. Like, solving competitions is cool, but people solve competitions to prove that they can go to the actual like frontier level job and solve new technical problems. And this is kind of what we want from our models as well.
We alluded to this a second ago. So mentally, at least for somebody like me, I understand how RL could be used very effectively to train against math problems or coding problems. I think one of the big questions right now is, how do you do that for the rest of the world in context and disciplines where the answer is not right or wrong, maybe a little more murky, and the rest of the economy, like you guys as an organization came up with a GDP val the other day, which is a way of evaluating performance against different industries. What is your thinking in terms of generalization of RL as a path to success for the rest of the world?
I think like the short and quick answer is like, somehow humans can learn all those things. And as long as there is any way to evaluate performance and figure out if something is going right or wrong, and you can compute that feedback, like you need to be able to somehow calculate how well something did, then you can optimize it, and then you can do reinforcement learning with it. I think like there can be an argument that if there is no notion of what is right or what is wrong, then also like humans are not able to improve and learn, because there needs to be a learning signal that coming somewhere. There is mostly a question of like how convenient and how easy is it to get that feedback, and everyone doing reinforcement learning should strive and try to be able to train on more and more complex and interesting training signals to do. And like very often there comes a notion of what is often called reward hacking, and like what happens when doing reinforcement learning, it happens a lot, and it's an important problem. You shape your reward in some way to reward certain behaviors, but sometimes it is the case that what you reward is not what actually you want. There is like one thing you need to train them all to do the behaviors you reward, but there's also a natural like mismatch about the reward that you give them all and what you actually want. And there are sometimes moments where the model does what you reward, but it's not in the spirit of what you had wanted, and we need to fix it. It's almost like a parenting challenge, and like you can, in some way, you can say it's a limitation of reinforcement learning. But when I was thinking about it, I realized a lot of that happens in human systems as well. There are a lot of like incentive system and reward systems, and even happens in workplaces, in all kind of human groups, that humans have rewards that are not always optimized for the ultimate goals of the system, and they hack rewards constantly in many different ways. And there is a constant whack-a-mole game between setting the right rewards and seeing if the system does it. And it's a huge like issue in any policy making almost, and any incentives programs. And it's the same kind of like whack-a-mole game in reinforcement learning research, trying to make sure your rewards are better and better representing what you actually care about the model to be doing.
All right, so maybe to zoom out to close this conversation, you said the other day, you tweeted, we all collectively believe AGI should have been built yesterday. And the fact that it hasn't yet is mostly because of a simple mistake that needs to be fixed, which is super awesome as a tweet. Do you think that the combination of pre-training and scaled RL takes us to AGI?
Like there's always an interesting question of like what do we consider something that is not pre-training on RL, and like where is the limit? I generally think something that we are doing like pre-training today is necessary. I think something that like we are doing RL today is necessary, and there will surely be a few things more, and like we have a lot of very ambitious research programs on some of those things. And like I don't think like the question of distance in research space is hard to say. Like for some people, like what we want to do and what we are planning to build is not very far from those things. For someone will say, oh, it's completely different, and it's like very much not that. So I don't want to go into like debates whether it's the same or not. But like we are and want to be constantly changing the way how we train the models to more represent what we think the right form of intelligence is, and the most useful form of learning is, and constantly are researching various things. And then the distance from like what is the distance from AGI is also like a very complex question. I really like someone said it to me, but I think it is right that if you talk to someone from 10 years ago and show them ChatGPT from today, they would probably call it AGI, but we are not today because it still has a lot of limitations, and we are all very aware of those limitations, and we are pretty sure we can resolve those limitations. There will be probably some further limitations of the future models that will need to be fixed. There is an ultimate question which is very hard to answer. When is the moment that the model can like improve itself without that much like external output and without humans working on it and fixing it? And I think it is a very hard question. It is a serious question that we need to try to answer. Humanity needs to tries to answer, because like the models that one will still like largely depend on like our infrastructure and our systems, but we'll be able to start fixing itself without us having to fix it. And that's like the predictions of what really AI will be able to do and will be able to solve at that moment start becoming like a little bit murkier than what we can do right now, which I think we still can do that pretty well.
But philosophically, you may have heard Richard Sutton, the other day on the Dwarkish podcast, which is a wonderful episode that people should really listen to, effectively saying that the only path to AGI was going to be pure RL, and that fundamentally LLMs, and maybe I hope I'm characterizing what he said appropriately, but that LLMs were a flawed premise because effectively that was imitation of reality, whereas RL was enforcement of reality. Do you have any thoughts and sort of like philosophically on that question?
Yeah. I haven't had a chance to fully listen to that episode yet, so I also don't get all the details of that of that thought. But what I can say is that we are doing quite serious RL on language models these days, and like I don't like in terms of a pure RL, I don't think like really pure RL makes sense. RL needs pre-training to be successful, and I think pre-training, as I said before, needs RL to be successful as well. I don't think without RL it would make sense. The research program we are doing, but we are like OpenAI is, and I'm pretty sure all other AI labs as well, very serious about doing a lot of reinforcement learning on our models. And I think like what kind of like a lot of people are saying that whether LLMs are an on-ramp or off-ramp of AGI, very often they do mean like pre-training, but it's also clear that like, the current way how we are doing things like also is not yet enough and is not yet everything, and there will need to be a further changes to the setup. But sometimes like people say, oh, if you are doing RL, it's not LLM, it's something else. Sometimes say, oh, if you can write program in your rollout and it's a chain of thought, it's not it's a neural network only, it's a neural symbolic system. So it's like, it's easy to get like some people consider something an LLM and the other thing not. But like personally, my view is what we have is a pretty good foundation for the next step of like we did have transformers first trained for translation, then we were pre-training them on large scale data, then we were doing RLHF on them, now we are doing large scale reinforcement learning. We'll do a few more and more complex thing. There is a chance somewhere along the line the architecture will start changing more or less significantly, and I think I personally think we are on the right path, and it will feel less like completely turning around and more like keep on adding more things and maybe like dissolving some old elements that carried us to the particular level of intelligence and were not needed anymore.
Well, that feels like a wonderful place to leave it. You've been very generous with your time and thoughts and giving us a glimpse into OpenAI, what you work on, what it looks like behind the scenes, and the key aspects of pre-training and scaling reinforcement learning. So it's been a wonderful conversation. Jerry, thank you so much. Really appreciate it.
Thank you very much. I enjoyed being here a lot too.
Hi, it's Matt Turk again. Thanks for listening to this episode of the Mad Podcast. If you enjoyed it, we'd be very grateful if you would consider subscribing if you haven't already, or leaving a positive review or comment on whichever platform you're watching this or listening to this episode from. This really helps us build the podcast and get great guests. Thanks, and see you at the next episode.